Welcome back, STEAM cadets! Professor L here, head mentor of the STEAM universe, and I am thrilled to welcome you to Mission 007. Today, we're jumping straight into your GEC 2026 Technology Worksheet 5B, specifically targeting questions 5.5 and 5.6. Our overall mission, to learn how to actually communicate our ideas like true design engineers. Because, engineers don't just build things randomly. They plan, they design, and most importantly, they communicate those incredible designs through accurate, technical drawings. By the end of this explainer, you're going to have the exact blueprint you need to absolutely conquer these questions. So, our mission objectives for today are broken down into two main phases. First up, question 5.5, where we'll master standard circuit symbols to draw a really neat circuit diagram. Then, for question 5.6, we'll shift gears and sketch out a professional 3D isometric housing structure for your alarm system. All right, let's dive right into that first objective and tackle question 5.5. We need to draw the circuit diagram for your intrusion detection alarm system. Now, I want you to think of a circuit diagram exactly like a road map. Just like a map shows cars exactly which streets to take to get where they're going, a circuit diagram tells electricity exactly where to flow. And instead of drawing highly detailed, complicated pictures of real batteries or real buzzers, engineers use a universal language. We use standard circuit symbols. Why? Because whether you're working right here in South Africa or over in Japan or Brazil, every single engineer in the world understands these exact same symbols. It's totally universal. Before we start sketching, let's quickly meet our circuit team characters. Think of each component as a tiny superhero with a very specific job to do. The battery, that provides the energy. Literally nothing works without it. Then we have our SPST master switch, which controls the on-off flow, opening and closing the circuit just like a door. Next is our LDR, or light-dependent resistor. It senses light, basically acting as the eyes of our alarm. Our transistor is the smart gatekeeper. It can act as a switch and even amplify a tiny current into a much bigger one. The LED gives us a glowing visual warning. The buzzer provides a loud, audible warning to scare off any intruders. And finally, the resistor. That acts like a little speed bump, limiting the flow of electricity so our components don't get damaged. Okay, grab those pencils, cadets, because we are going to draw this out step by step together. Step 1, always begin with the battery for your power source. Now for step 2, neatly add the SPST master switch right near the battery. Remember, this guy controls the entire alarm. Step 3, draw your resistor and our light-sensing LDR in their correct positions. And then step 4, place the transistor carefully right in the center. It needs to sit there to act as our smart gatekeeper, connecting the sensor part of our circuit to the output part. Let's keep that momentum going and add our alerts. Step 5 brings in our LED for that absolutely crucial visual alert, which is super important for people with different hearing abilities, by the way. Step 6 brings in the buzzer for our loud noise. And finally, step 7. Now listen closely, this is vital. Join every single component using perfectly straight lines. These lines represent your connecting wires, and you absolutely must use a ruler for this. No freehand, wobbly lines allowed. The big takeaway here is that engineers absolutely love neat drawings. So watch out for the mission hazards you see here on the right. To get full marks on your assessment, you want to avoid the common villains: untidy freehand wires, using the wrong symbols, forgetting your master switch, and crossing wires unless the circuit specifically requires it. A messy diagram is a confusing map, and trust me, electricity does not like confusion. Actually, I'm going to pause the explainer right here for a quick cadet challenge. Let's test your active recall. Look down at your worksheet and see if you can point to and identify the LDR, the battery, the switch, the LED, and the buzzer entirely on your own. It's one thing to draw them step by step, but being able to read a circuit diagram like a detective, that is a true engineering superpower. And just look at how beautifully this illustrates every component working together. You can actually trace the flow of the entire intrusion detection system. The current travels right from the 6-volt battery. When light hits that LDR, its resistance drops, and it sends a tiny signal to the base of our NPN transistor. The transistor amplifies that signal, opens the gate, and boom, it allows a much larger current to flow through, immediately powering up the LED and the buzzer. It is just a perfect chain reaction of engineering. All right, mission half complete, cadets. Let's blast right into question 5.6 and tackle the physical 3D design of the housing structure that's going to actually hold your amazing circuit. Now, if you've never drawn an isometric projection before, don't panic. Just imagine looking at a transparent gift box right from its front corner. By looking at that corner, your eyes can see three distinct sides: the top, the front, and the side, all at the exact same time. This is exactly why engineers use isometric sketches. It gives a highly accurate, totally realistic representation of what your final physical prototype is going to look like in the real world. So let's sketch this housing slowly together, literally one line at a time. Step 1, gently sketch the top rhombus to define the roof of your housing. Step 2, drop down your straight vertical edges to set your height. Steps 3 and 4 complete your front and side faces to box the whole thing in. And finally, step 5, you're going to take a slightly darker pencil and darken only the visible outside edges. This is what makes that fantastic 3D shape really pop off the page. Awesome. Now we need to mount our electronic components to turn this from a simple box into a legit alarm system. So, step by step, carefully sketch in the LED protruding right from the front so it's super visible. Add the LDR eyes where they can easily detect any light changes. Draw the warning buzzer on the side. Place your master switch where someone can actually reach it to turn the system on or off. And finally, sketch that battery compartment on the back or inside to keep your power source secure. But remember, a great drawing is absolutely nothing without clear communication. A good engineer always communicates their ideas clearly, so make sure you use straight, neat leader lines to label every single feature on your new 3D sketch. Literally draw a straight line from the LED to a clear, printed label that says LED. Do the exact same thing for the LDR, the buzzer, the switch, and the battery compartment. This just ensures that anyone looking at your design knows exactly what they're looking at without having to guess. And here's a pro tip. Your explanatory notes are just as important as the drawing itself. These notes are where you reveal your brilliant engineering thinking. They prove to your assessor exactly why you made the specific design choices you did. For instance, writing "made from recycled cardboard" shows you're actually adhering to material constraints. Or writing "LED positioned on the front for maximum visibility" proves you are genuinely thinking about the practical, real-world function of your alarm. All right, cadets, here is your ultimate cheat code for unlocking full marks on that Worksheet 5B assessment rubric. Before you even think about handing your worksheet in, check this list. Is your 3D isometric sketch accurately proportioned? Check. Did you include those brilliant explanatory design notes? Check. Are all your labels drawn with correct, neat leader lines? And finally, does your idea actually meet all the given specifications and work within the constraints, like using a maximum 9-volt battery and utilizing recycled materials? If you can tick all those boxes, you are officially operating at peak engineering levels. As we wrap up this explainer, I want you to remember my absolute favorite mantra. Every great engineer begins with a great design. We don't just build things blindly hoping they work. Accurate drawing, careful planning, and clear communication. That is exactly how we bring our world-changing ideas out of our minds and into the real world. You are learning the true language of design today. Outstanding work today, STEAM cadets. You have officially mastered circuit symbols, the flow of electricity, and the art of 3D isometric sketching. But I'm going to leave you with this final provocation as you finish up your worksheets. Will your isometric sketch remain just a pencil drawing on a piece of paper? Or will you use these skills to create the very blueprint for the future of security technology? Keep planning, keep designing, and I will see you on the next mission in the STEAM universe.